Welcome back. In the next couple of sections, we're going to jump into the different hyperparameter optimization methods that we can use. But before we do so, I wanted to recap on the things that we need to consider when we choose these methods. We said that the process of finding the best hyperparameters for a given dataset is called hyperparameter optimization or hyperparameter tuning. And the best hyperparameters are those that will maximize the performance of the machine learning model. We also discussed that the hyperparameter search consists in a hyperparameter space, that is the various hyperparameters that affect the machine learning model, and we discussed many of these in section 2. A search also has a performance metric that we want to minimize or maximize, and we discuss performance metrics in section 3. A search also has a cross-validation scheme to estimate the performance and the error, which we discussed in section 4. And in the next couple of sections in the course, we're going to discuss the various methods available to us to sample different candidate hyperparameters. Now, there are a few challenges to select the best hyperparameters. The first one is that we can't define a formula to find the hyperparameters, so we're basically left out with trying different combinations of these hyperparameters and then evaluate the model performance. So the critical step is to choose how many different hyperparameter combinations we're going to test. Intuitively, we would think that the higher the number of hyperparameter combinations, this is the more hyperparameters we test, the greater the chance to get a better performing model. And this is true to some extent, but also the greater the computational costs. We also discussed the low effective dimension, which is the fact that some parameters affect performance of a machine learning model a lot, but many hyperparameters do not have a huge effect on model performance. For example, we saw that while the number of estimators in a decision tree have a huge impact on the performance of the model, the minimum samples per split don't have such a great impact. But not only that, there is a number beyond which the performance of the model does not increase. So it is more useful to search hyperparameters in this region than in this region. Another thing that we have not discussed is that the nature of the hyperparameters matter. Some hyperparameters are discrete, for example the number of estimators in ensemble methods, and some hyperparameters are continuous, for example the penalization coefficient or the percentage of samples per split in a decision tree. And then there are some other parameters that are categorical, for example the loss function or the regularization function, for example lasso or reach. And this affects how we select hyperparameters because the hyperparameter space for continuous variables is bigger than those for discrete or even binary hyperparameters. For example, should we use a penalization coefficient of 0.1 or 0.11 or 0.15? And when it comes to the number of estimators, should I use 1 and then should I compare also 2 or 3, or should I compare in tens, for example? 10 estimators, 20 estimators, or even exponentially, 10 estimators, then 100 estimators. Some of this insight we get as we train more and more machine learning models. So to sum up, when we create hyperparameter sampling strategies, we need to consider the number of hyperparameters that the machine learning model has. The more hyperparameters, the more time my searches will take, because I need to test more combinations. But then we need to also consider the low effective dimension, so that we do not search in spaces where the performance of the model does not increase further, or that we do not search hyperparameters that don't affect the performance of the model much. Then we need to think about the nature of those hyperparameters, which intervals of values should I test, and then of course the computing resources available to us. In the rest of this section, we're going to discuss the first three hyperparameter search methods that were used, which are manual search, grid search, and random search. That is all for this video, and I'll see you in the next one.